Hello everybody. Today we are going to be going over sigma notation. Now sigma notation is very easy to understand, and I'm telling you right now there is a sequence to this. I was trying to find a way to put series in this one as a pun, but unfortunately that was close enough. So I guess it was kind of fortunate, but it was unfortunate at the same time. Anyway, let's get straight into the explanation. So what happens if I do the following? I say that I have some sigma notation, which is represented by sigma. Sigma is clearly just the Greek, a part of the Greek alphabet. This is the capital letter sigma. The small letter sigma is represented by this. I think there was another one though, and I can't remember that one, but I just know that. But this is big sigma, big boy. So what do we say about sigma? Sigma is just the sum from our lower limits, which we could say k equals 1, until k equals to what? Let's say n. Okay? But let's rather start with actual values to understand what is happening. 1 until 5. And if we say that we're working with k, then what does that actually imply? We will have a whole bunch of sequences, or series, a whole series where we start from 1 and we'll work our way all the way to 5. Step by step by step. So this implies to us that we are going to have, where k is equal to 1, we start plugging in. So we start with 1 plus, what's the next one? It's going to be 2. And it's always going to be in whole numbers. Plus 3, plus 4, plus 5. So we're working our way all the way from k equals 1 until k equals 5. This is what you call the lower limit, and this is the upper limit of the sigma notation. And then we just add them together, right? 1 plus 2 plus 3 plus 4 plus 5 is the same as saying, so it will be 1 plus 2, which is 3, plus 3, which is equal to 6, plus 4 is 10. This will be 15. Okay? So k equals 1 until 5 is just 15. What if we have a different type of example, right? If I say the sum from k equals to 0 until 4 of, let's say, k to the power of 3, right? Then what's going to happen here? I'm going to start from k equals 0 and I'm going to work my way all the way to 4. So what is that going to imply? Wherever I see k, I'm going to replace with from what we have on our limits from the summation. So therefore we start at 0. K is equal to 0 cubed. Plus, what's next? 1 cubed. Plus, what is next? 2 cubed. All the way to 4. So plus 3 cubed plus our last one, which is 4 cubed. Which is just going to be equal to what? Jeez, this is a lot to even calculate. So it's just 0 plus 1 cubed, which is 1. 1 plus 2 cubed is equal to 9. 9 plus 3 cubed is just equal to 36. And then we have 36 plus what? 4 cubed, which is just equal to 64, is just essentially going to be 7. That's going to be 100. I hope it's 100, by the way. I just speedrun that math. But hopefully you get the idea. So what if we bring this into our actual series notation? So that is where we're going to start with the first example now. Now that you have an understanding of how to deal with this, this is where we deal with our understanding. Also, one small little thing, by the way, to find the number of terms, to find number of terms, we need to do the following. We need to take the highest value, so it'll be top, which is, I'm rather going to color code it, by the way. So the top is represented by purple, the bottom is represented by orange, so that's 0, and then obviously it's going to look like this. So the top minus the bottom, which is going to be orange, and we are always going to add it by 1. This is equal to our number of terms. Okay. So if they ask how many terms are within the sigma notation, we take the top value, subtract it by the bottom, and then we just add by 1. Okay. So let's get into the actual examples and see how we apply this. Alright, so we are asked to evaluate the sum from k equals 1 until k equals 13 in the form of, what on earth is this nonsense over here? This is a k. Alright, there we go. Of 3 plus k minus 1 into 3 over 2. Okay. So clearly what we are working with here is the following. We need to actually point out what is the series that we're really working with. Because remember, we are actually still dealing with series. Okay. So this is how we are going to expand it. It is from k equals 1 all the way to k equals 13. So therefore, what are we saying? The series looks like this. So it's basically going to be 3. So the first term is going to be 3 plus what? Oh, it's actually better to do it this way, sorry. Term 1 is essentially when we plug in k equals 1, right? Because that's where we start. And then therefore, that just implies we're going to have 3 plus what? 1 minus 1 into 3 over 2 for this one over here, okay? And then we just evaluate this. So it's going to be 3 into what? 0. 3 plus 0, which is just 3. Okay, so we're starting at 3. Term 2 is just going to be, so usually I would say do the first 3 terms. So term 2 is just going to be 3 plus what? 2 minus 1 into 3 over 2, which is the same as 3 plus 3 over 2, right? Because it's times 1. And then we know that if we rewrite this, it's just going to be 3 over, well, I guess we want to say 2 as a denominator. So it'll be 6 over 2 plus 3 over 2, which is just going to be the same as 9 over 2. So therefore, this is 9 over 2, which is the second term. And then term 3 is just going to be 3 plus 3 minus 1 into 3 over 2, which we know this 2's are going to cancel because 3 minus 1 is 2. And then we're going to have 3 plus 3, which is equal to 6. Okay, and then what's going to happen? It's a series that's all the way until the 13, the number 13. So we're going to go all the way, so I'm going to say dot, 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 all the way to term 13, which is going to be what? 3 plus 13 minus 1 into 3 over 2, which is the same as 3 plus 13 minus 1, which is just 12. So we're just going to say 12 multiplied by 3 over 2, which is what? 12 divided by 2 is just basically going to be 6 over 1. 6 times 3 is just going to be equal to 18. 18 plus 3 is 21. So therefore, the series will look like this. It'll just be T1 plus T2 plus T3 plus dot 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 all the way to T13 in this case, which essentially tells us that we are going to have 3 plus, let me actually leave a space, 3 plus 9 over 2 plus 6 plus dot 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 all the way to 21. And you can see we stop at 21. So here's our series now, okay? So we just formed the series from our sigma notation. How cool is that? Using what we learned here. So we need to determine, is this arithmetic sequence or is this a geometric sequence? So in order for us to figure that one out, we essentially need to see, is term 1, sorry, so term 2 minus term 1 the same as term 3 minus term 1? I mean term 2, sorry. Well, let's see. Term 2 is 9 over 2, and then we're minusing that by 3. And this is equal to what? Term 3, which is just going to be 6 minus 9 over 2. So let's see if those are the same, right? So 9 over 2 minus 3 is just the same as 9 over 2 minus 6 over 2, which is just going to be what? It's going to be 3 over 2. And this on the right hand side is essentially just going to be 6 minus 9 over 2. And we can write this as 12 over 2 minus 9 over 2. And then 12 minus 9 is just going to be equal to 3 over 2. So what does this tell you? Because our test for arithmetic series worked, or sequences worked, therefore this thing is arithmetic. So which means we'll use the formula that we are given. But my question is, do we know what the final term is? Yes. So we will be using the formula Sn equals n over 2 into a plus L, where L represents the last term of the series. A is the first term of the series when we started with the summation, with the sigma notation. And n, do you remember what n was? N is just represented by what? N is represented by the top minus the bottom plus 1, which is the number of terms, remember. So essentially, we're going to take 13, we are going to subtract it by 1, and then we're going to just add by 1. Okay. So we know that n is going to be equal to 13 minus the bottom, which is 1, and we're just going to add 1. Okay. So it's going to look something like this. And therefore, it's just going to be 13 minus 1, which is 12, plus 1, which is 13. So n is equal to 13. So therefore, this implies to us we're finding the sum to 13 terms. And then we have n equals 13, so it's over 2, multiplied by a, which is 3, plus the last term, which is 21. And then therefore, what do you notice? The answer is just going to be 156. So that is essentially how we use summation in order to find the series. So that's basically all you really need to know with the summation. But my question is, what happens if we're dealing with geometric series? We'll see. Alright, so here we need to solve for n if the sum from 1 until n of this, everything in here, 3 times 2 raised to the power of k minus 1 is equal to 381. Now, what we really need to do in this case over here is we need to evaluate this all the way to n amount of terms, okay? And then we'll know what the answer is as well. But let's just try and do that, right? So first things first, we need to know what term 1 is. So when k is equal to 1, it's just going to be 3 into 2 multiplied by what? 1 minus 1. And then obviously it's going to be an exponent of 0. So it's just going to be 3 times 1, which is 3. Term 2 is just going to be 3 into what? 2 raised to the power of 2 minus 1, which is 3 times 2, which is 6. Then T3 is just going to be 3 multiplied by 2 raised to the power of 3 minus 1. This is going to be 3 times 2 to the power of 2, which is 4. So 3 multiplied by, am I going crazy? Raised to the power of 2, that's going to be 4. And that's going to be 3 times 4, which should be equal to 12. I'm not going crazy, just tired. So now we did the first 3 terms. So let's do all the way to the nth term. So Tn is just going to be equal to 3 times 2 raised to the power of what? N minus 1. Okay, so we don't know exactly what that's going to be, but we just know it's going to be in place of n. So therefore, what this implies to us is that when we take the series of all of them, we are just essentially going to get 3 plus 6 plus 12 plus all the way until 3 into 2 raised to the power of n minus 1. And the sum of everything, what did it say it was going to be, is 381. And do you not agree with me that this entire thing is just Sn? Okay. And that is essentially what the summation is, right? It's a sigma notation. This is actually Sn. So the sum to a certain amount of terms all the way to n amount of terms in this case. So therefore, what that actually implies to us is we are going to notice that we will have to find out a formula for Sn. Is it arithmetic or is it geometric? But clearly what we notice is it is geometric, but we need to first show our reasoning. So if we say term 2 minus term 1 equals to term 3 minus term 2, then notice we're going to just take this term 1, term 2, term 3. It's going to be what? 6 minus 3, and then it's equal to 12 minus 6. 6 minus 3 is 3, and then 12 minus 6 is just equal to 6. Since they're not equal to each other, therefore the test for arithmetic does not work. Let's test geometric. To test geometric, we will show that T2 over T1 is equal to T3 over T2. Therefore, we're going to say that 6 over 3 is equal to 12 over 6, which obviously says that 6 over 3 is a half. It's 2, and 12 over 6 is 2. And therefore, since they're equal to each other, this will be geometric. Okay. So therefore, we will use the formula Sn equals, and since this value is indicating r is greater than 1, then therefore we will use the formula where clearly we have r first. So it'll be a into r to the power of n minus 1, all divided by r minus 1. Okay, because we obviously use it when r is greater than 1. And therefore, we need to just solve for n. Okay? But in order to solve for n, we need to see if we have other parameters, such as a. We need to know what a is. We also need to know what Sn is. And we also need to know what r is. And we do know what those are. Sn is actually equal to 381, as we just deduced. So which means we can say it's 381 in place, right? Is equal to a, which is 3, the first term, and then r is equal to 2 raised to the power of n minus 1 divided by r, which is 2 minus 1. And then we just keep simplifying. Okay, 381 equals to what? This is divided by 1 because 2 minus 1 is just 1. Therefore, we have 3 multiplied by 2 to the power of n minus 1. Divide both sides by 3. We are going to get the following. We're going to just say 381. So 381 divided by 3 is just 127, right? So just dividing both sides by 3, and we're left with 2 to the power of n minus 1. And we add both sides by 1 to get rid of the negative 1 on the other side. Therefore, we're going to have 128 equals 2 to the power of n. And we find the factor with the prime factor, a prime base with this value 128. If we say 128 equals fact, we will get 2 to the power of 7 is equal to 2 to the power of n. And remember, because the bases are the same, right, we need to let the exponents be the same in that case to make this equation true. So therefore, this further implies to us that n is equal to 7. And do you notice that we just solve for n? And that is how we deal with sigma notation. So it's really not that bad. It's just you need to get into it, and then it should be fine.